Obscuris from the Comet team. And on behalf of our new partnership through SageMaker AI Partner Apps, we would love to welcome you all to our webinar this afternoon on streamlining GenAI system evaluation and observability with Amazon SageMaker and with Comet. So today we'll explore how integrating both of these powerful tools can enhance your AI development workflows, all the way from tracking experiments to production monitoring for both sort of Gen AI and agentic and also traditional machine learning applications. Before we jump in, I'd like to take a moment to introduce our speakers. As mentioned, my name is Nico. I'm VP of Go-to-Market here at Comet, focusing on AI product adoption and market strategies with all of our customers and partners. And I'll hand things over to my colleague, Chase.
Everyone, my name is Chase. I lead solutions engineering here at Comet. So I'm a technical resource for our customers, helping get the OPIC platform like you'll see today, and also the rest of the Comet solution integrated into various MLOps ecosystems. So nice to meet you all, and thanks for joining.
Hi guys, I'm Nofel. I'm a specialist solution architect at AWS, focusing on the SageMaker platform. I work very closely with the SageMaker service team. Yeah, nice to meet you all.
Hi everyone, welcome to our session. My name is Jia, and I am a principal go-to-market specialist at AWS for SageMaker.
Awesome, thanks everybody. So let me quickly cover our agenda and then we'll dive in. So today we're going to cover a few different topics. So we're going to do a brief introduction to SageMaker, understanding the tool, the entire platform and ecosystem, all of its capabilities in the AI ML landscape. We'll do something similar with Comet. So we'll introduce you to our company, what we've built, how we support some of the best companies in the world, and how Comet can enhance your AI development and monitoring. We'll discuss the partnership that we launched with the SageMaker team at reInvent this past December, and we'll talk about the partnership, sort of the motivation behind that partnership, the benefits that sort of hypothetical customers can get from adopting, running Comet on SageMaker. And we'll touch on the architecture of the system to give you a good mental model for what that looks like. Next, we'll talk about sort of a typical GenAI customer journey and how you can think about the two tools fitting together to facilitate and enhance such a customer journey. And then we'll dive into a technical demo where we actually show this all live, and we'll show sort of a traditional RAG application use case built using SageMaker and Comet. We'll wrap up with some additional resources, and we'll try our best to save some time for a Q&A at the end. One note to all of the participants: if you have any questions during the presentation, you are encouraged to post them in the chat, and either myself or one of our other presenters will either answer any questions that arise in the chat, or we'll save them and discuss them live at the end of our talk. So without further ado, I'd love to hand things off to Gia to handle our introduction to SageMaker.
Yeah, thanks, Nico. I'll do a quick intro on the Amazon SageMaker. So Amazon SageMaker is a machine learning service on AWS that provides tools to build, train, and deploy machine learning models at scale. It simplifies machine learning workflows by offering a managed infrastructure, manage model lifecycles from build to deploy, and integrates with other services on AWS. SageMaker enables machine learning practitioners to collaborate and build faster with a single data and AI environment, accelerating time to production. It offers a broad set of tools for data scientists and ML engineers to build, deploy, and scale across both traditional ML and GenAI use cases. With an open lakehouse approach, customers can unify data across silos to build higher quality models and applications faster. And lastly, SageMaker has built-in data and AI governance to control access, manage permissions, and help govern models or applications across their life cycles, meeting any necessary compliance and responsible AI requirements. Now, as shown in this diagram, Amazon SageMaker provides a complete stack for your machine learning needs, starting with the lakehouse that unifies your data across silos and databases, governed by a data and AI governance layer, and then enabling various processes ranging from data processing to SQL analytics to machine learning and GenAI development, all fronted by the SageMaker Unified Studio. Now, today our session is focusing on the GenAI app development area, as you see on this diagram.
Perfect. Thanks so much, Gia. So switching gears and giving the audience a brief introduction to Comet. Comet's an industry-leading platform designed to manage and optimize the entire machine learning lifecycle for both traditional and GenAI-based workflows. Our core functionalities include the model registry, so a centralized repository for managing model versions, ensuring reproducibility and streamlined deployment processes, experiment management, centralized tracking of ML experiments, allowing users to log everything you need to reproduce research, so hyperparameters, metrics, dataset samples, visualizations, etc. Production monitoring, so extending that observability into production, allowing teams and individuals to do things like monitor model performance in production environments by detecting data drift, performance degradation, so on and so forth. And finally, extending all of this to the world of agents and GenAI applications. So we'll talk a bit about our new product, OPIC, but powering GenAI application building, LLM evals for some of the best companies in the world. So you'll notice some of the companies that Comet supports. Many of these are Amazon customers as well. And a brief note about sort of where we are in our company life cycle. We've raised about $70 million. We power over 250,000 ML practitioners around the world. We have a workforce in over 11 countries. And fun fact, Amazon was one of the first investors in Comet. So it's very exciting for us to be working on a partnership here with the Amazon team. So a quick note about the evolution of the space and how this plays into the partnership. So over the last couple of years, Comet has evolved our platform to meet the growing demands of practitioners and teams around the world building Gen AI applications with OPIC, which is our open source and at this point the most popular LLM evals framework out there. And so what makes Comet a unique AWS partner, and as you think about building on top of SageMaker and Comet, it's the only tool out there that provides end-to-end observability across both traditional machine learning and GenAI workflows, and plugs in very, very nicely and elegantly to the SageMaker ecosystem. So no matter what type of ML work you're doing, whether you're building scikit models for traditional use cases or building RAG applications on top of the newest model on Bedrock, Comet's observability layer will have you covered, and now will integrate effortlessly into the rest of your SageMaker ecosystem. So one of these things, this has been a constant for us throughout our journey as a company, is we've always been an observability layer on top of underlying infrastructure for storage, for compute, for orchestration, et cetera. And as a result, we've always worked very, very closely with Amazon, in particular the SageMaker team, to offer customers a powerful unified experience. And so when we had the opportunity to build a more elegant integration and partnership with the SageMaker folks, it seemed like an obvious opportunity to deliver real customer value in a powerful way. So on that note, I'm going to hand things over to Nafal to talk a bit about our vision for the partnership and some of the value that customers can expect. So Nafal, feel free to take it away.
Thanks, Nico. Yeah, guys. So when talking about the partnership, right, from SageMaker point of view and the Comet, so the thing that we launched at reInvent was the AI Partner Apps solution, which takes industry-leading AI partner applications such as Comet and offers them managed within the SageMaker environment. So AWS manages the hosting of these applications as well as upgrading them and all that fun stuff. Obviously, one of the benefits you get is the private offering, which is your data doesn't need to leave your AWS environment. as well as obviously you're getting the managed offering of these applications automatically hosted directly within the AWS environment. Right at the end of today's session, we'll show you a quick preview of how easy it is to get Comet provisioned within AWS directly from the console. And after the deployment, it's pretty easy to access, which we'll show you through the demo as well. Yeah. Yeah, so obviously we did talk a little bit about the benefits that come with having the application fully managed within the SageMaker ecosystem as well, right? But the Comet folks will talk a little bit at the end. Please hold your questions about that. But there will be some metrics on how having the application hosted managed helps accelerate the ML lifecycle anyway. This is on beyond the metrics that you see on the right side of the screen, which Comet have gathered from their many customers, is on how you accelerate model development and so on by having an application like Comet. Next slide, please. Thank you. Cool. I think
Yeah,
hand that over to Gia. Thank you.
Okay. Yeah, thanks, Default. So let's take a look at a typical GenAI customer journey, right? You start with qualifying the use case for development. You have teams that analyze the purpose and the risk level of the use case, and once that is approved, the project gets kicked off, where the platform engineer onboards the users and with the right roles and permissions, and provisions the resources on SageMaker. Then the build process starts. This is where data scientists begin to build the GenAI application. This stage may involve customizing and evaluating foundation models, fine-tuning them, experimenting with different configurations before deciding whether the model or the application is performing well enough and cost-effective enough to be deployed. As we'll see later, Comet is critical in providing the experiment tracking and the model evaluation at this stage. Once the model or the application receives approval to be deployed into production, Comet or OPIC, once again, is key to observe, monitor, and gather the tracing data to understand how well the model is performing. In this case, again, OPIC is really important because it captures the traces to allow the customers to understand the different corner cases where the model does not perform well. And they can be then brought back to the evaluation data set so that data scientists can begin to improve the model and their applications with SageMaker AI.
Awesome. Thank you, Gia. And so we'll dive into the exciting part of this presentation, which is going to be our technical demo. So in a few minutes, we'll hand things over to my colleague Chase to run through an end-to-end demo showcasing a typical GenAI workflow built on a platform powered by Comet and SageMaker. This will be sort of a typical RAG-based AI assistant, leveraging both ecosystems as much as possible. So more concretely, we'll be covering several common workflows and use cases. So we'll be creating an assistant app, retrieving context using a simple RAG pipeline, and then calling an LLM with context and user questions. For this, we'll be using SageMaker notebooks, Bedrock, and keeping track of everything in OPIC from Comet. Next, we'll be setting up some evaluations for this assistant app. So we'll create a system prompt, a golden data set, and then some evaluation metrics against which we can run experiments. These artifacts will be stored in OPIC, and everything, again, will be run on SageMaker. And finally, we'll repeat this evaluation with different system prompts to simulate the iterative process of shipping and improving a GenAI application. So a couple notes before we jump into the demo. And one of the key aspects of value that comes from leveraging Comet and SageMaker's partnership is the way that it adds value to all of the different personas who might be involved in building GenAI applications, from the engineers to the data scientists to the admins who are provisioning infrastructure for the end users. So I want to take a brief note and just go through some of the things to look out for depending on who you are on this call. So From an admin perspective, it's worth noting that we are not going to go through the full exercise of provisioning Comet inside SageMaker. It's very easy to do so. We'll be sharing some instructions at the end of our talk, but it's a few clicks of a button and everything is synced right to your SageMaker workspaces. So pretty effortless, but just so you know, we're going to assume for the purposes of this demo that Comet has already been provisioned. If you're a data scientist or someone doing the real ML work, a few things to highlight here that could be valuable for your day-to-day. Obviously, building a RAG in SageMaker AI Studio notebooks is a key component of any person building GenAI stuff. Evaluating your RAG against a data set with Comet OPIC. So again, sort of a canonical exercise and evaluating the performance of your RAG system. Tracking experiments with OPIC again, so maybe comparing different evaluations, different system prompts, sort of different performances against that golden data set. And then finally doing some analysis, so comparing metrics across these data sets, prompt templates and RAG configurations. If you're an ML engineer, other things about this presentation may be interesting. So thinking about building a repeatable RAG pipeline based on this notebook, maybe looking at certain changes or alterations in the data set, the prompt templates, and setting up configurations that might trigger SageMaker pipelines to build a new version of the RAG application, so automating some of these steps. And then finally, maybe setting up some criteria to qualify a model for deployment into a production environment. If you're an MLOps engineer, again, some different things may be interesting. So you can use OPIC to monitor the RAG application for performance and latency. So think about extending this notion of evaluations to some questions or information or data that your GenAI app is seeing in production. And then maybe gathering all of that tracing data of user interactions to do things like updating the data set, monitoring health, and so on and so forth. And then the final persona that we want to highlight here is if you're a data engineer, it might be interesting for you to think about how this system will enable you to do things like building data pipelines to process tracing data for production to produce new evaluation data sets, again, to improve your RAG application iteratively over time and in a way that reflects the information that your agent or application is seeing in the wild. So just a brief note on the various personas and what might be interesting to you as we go through this demo. But that's all the preamble I will give. So I'm going to hand over one last slide to Nofal to talk a bit about the architecture of this system you're about to see live, and then we'll get started with our demo. So Nofal, over to you.
Yeah, thanks, Nico. Yeah, so guys, as Nico talked about the different personas, here we're just talking about from an overall architecture how this app actually looks like. So we got the app in the middle where your RAG application actually sits, which basically is talking to Amazon Bedrock, a Claude model, as Nico mentioned already. In the productionized environment, you'd have like SageMaker pipelines, which builds the application and triggers based on any changes to either the prompts, the data sets, any other changes you could think of, like chunking strategies and so on. And then obviously that kicks off an OPIC LLM evaluation job from the SageMaker pipelines, the results of which are captured back. And based on what Nico said, like, for example, we can have some criteria when it passes certain metrics criteria, we can upgrade the application and release a new version of it. Again, with OPIC tracing coming directly from the application into OPIC. You'll see a little bit of that when Chase walks it through the demo. But for the purposes of today's demo, we're not going to be showing you the pipelines because it's a bit more interactive if you get to see what's being done and actually see the code, all of that, which can be just packaged up into SageMaker pipelines. With that, I think I'll hand it over to Chase to show us the demo.
Awesome. Yeah, let me take over screen share here and we can jump into the demo. Okay. Um, I wanted to start by turning on my video to say hi to everyone and show you I'm a real person here, but I don't want to block the size of the presentation here, so I'll go off video as we jump into the demo. Just to confirm, can everyone see my screen here?
Yep.
Yep.
Okay, cool.
Yeah, we
I want to
can.
make sure that was successful. Awesome. So as you all heard in the slides, Comet is a centralized platform that's going to allow you to track, evaluate, and monitor both traditional and LLM models end to end. But today we're really going to focus on the LLM workflows, so our OPIC side of the platform. For teams that are working on training and fine-tuning LLMs, that for those workflows, Comet's experience tracking solution can also be used to track the fine-tuning runs, performance metrics, inputs and outputs in a way that's reproducible and easy to share with the team. But once again, what we'll focus on in the demo today is maybe once you've completed that process of fine-tuning, you have a model that you now want to integrate into your application. And it could be a fine-tuned model, but maybe also a proprietary model. In this case, we'll be using the Claude Sonnet model. We will be covering how Comet's OPIC solution can be then set up as a SageMaker API partner app to help with this entire evaluation workflow for the application during the development process, and then also how you can use SageMaker throughout that process to streamline evaluation and make it further automated so there's few manual steps. As mentioned, since we're kind of spanning the entire LLM lifecycle from development to production, we're going to cover kind of bucket it into three main workflows. So the first thing that I will cover in the session today will be using OPIC's evaluation capabilities and SageMaker to automate the process of evaluating how the application's performance or how the application performs with different models, data sets, RAG approaches, prompt templates, and other input tweaks before you actually move that application to production. We'll then, once that model is in production, we'll talk to how OPIC's tracing capabilities for observability can be used to track the model's performance in production, like you'll see briefly here. And then finally, connecting the two back, we'll talk about how you can use OPIC and SageMaker to find the production traces where things did go wrong and add them to an evaluation data set on a regular cadence so that you're always accounting for any of those production edge cases when you're going back to the drawing board and doing additional iteration on your model. So, with that high level, we can jump right into that first use case of going through LLM evaluation. The demo that I'm going to be doing today is based on a RAG chatbot use case, specifically using Amazon Bedrock to call the Claude Sonnet model. And this example will specifically be creating a Comet ML chatbot. So a chatbot for product and SDK questions for any Comet customers. So with that, let's jump in and I can actually show you what code goes on behind the scenes to help us trace and evaluate this specific use case. You'll notice that the code that I'm being run is being run in Jupyter Lab, hosted in SageMaker Studio. So all the code here is going to actually be run in SageMaker. To start, something worth noting, if you're using Comet and OPIC through an AI partner app, all you'll need to do is add in a couple lines of code here in order to properly authenticate to this specific instance. So you'll see here my partner app auth and ARN or something that you'd be able to get right from the Studio UI. And that's really all I need to add in order to start logging traces to the OPIC deployment on the AI partner app. Since it's a RAG use case, really the first step that we'll take is actually building out the vector store. In this case, I use Chroma and Hugging Face embeddings to set up that vector store containing Comet SDK documentation specifically, as you'll see here. But we are completely agnostic to the setup of the vector store and the RAG pipeline. This was just a simple example, but at the end of the day, what we're going to do is track the context retrieved from this step and then the final output of the model. So you can always take a look at what went wrong or what the proper context was that was retrieved, no matter what underlying vector store you're using or chunking strategy you're using, etc. If I keep going on here, now that I've set up the vector store, we really just need to define our LLM application. So in this case, once again, it's that simple chatbot. And my application here really has two simple steps. The first is going to be context retrieval in this retrieve doc step. So that's going to use that retriever that I built above. And then the second step in this Comet bot is going to be get answer. This is really the LLM call. So in this case, we're going to use Bedrock to call the Anthropic Claude 3.5 Sonnet model here. But once again, we are completely agnostic to the model. So you could switch out Anthropic to a Llama model or an OpenAI model. Maybe instead of using the Bedrock client, you could use a SageMaker Jumpstart model. We're very much agnostic to what's actually going on behind the scenes. So this is also something you could iterate on later, is maybe testing out switching a different model and seeing if you see better performance between different versions or model providers. To actually, we've built out the application, but to actually log all calls that are made to this application, all I'll need to do is add OPIC's track decorator that will automatically log inputs and outputs for each span within the trace. So you'll see here, I've added opic.track in front of both of the spans within my pipeline, and I'll show you this in the UI in a bit, but each time we call the model, you'll be able to see the inputs and outputs of each of these steps separately. Additionally, in this case, I've added the Bedrock wrapper to my init definition around the Bedrock client. What this does is, because we have a explicit native integration with Bedrock, we also can log some additional metadata about the LLM call itself, like token usage and the model used. So this will just be helpful to add some additional metadata. But once again, even if you're not using Bedrock, these track decorators will still help you get the key inputs and outputs and help you then score those traces as well. So in this case, we've now set up this Comet bot with really a two-step pipeline here. And I can go ahead and this would be the code to test it out. You'll see really the one thing, this specific use case, I have the model that I want to use, and let's say we're doing some system prompt engineering. So to start, as kind of a gut check, I'm just going to test out using one specific system prompt and passing in a question to it. Because of the decorators that I added above, this call and really any other call to my RAG will be logged to OPIC within SageMaker Studio, so we can go ahead and jump right to that UI. It's also nice because, like I mentioned, I'm running my code from SageMaker Studio. You also can jump to OPIC from the same place, so it really gives you that single pane of glass where all of the development is being done, both running of the code and then analysis of the results. As mentioned by Nico earlier, we're kind of making the assumption that you've already deployed Comet as a SageMaker AI app. At the end, I'll go through a quick workflow of what it looks like to actually provision this. But once it has been provisioned by an admin within your organization, Comet will just show up as an application in SageMaker Studio here, and you'll be able to easily click this button to open up Comet. I already have there we go. I've already opened up to the project that I wanted to demo here. So back to our RAGBot use case, I ran this simple trace through my application, and you'll see here this get answer call has now been tracked in the UI. Over time, this is nice because you'll be able to see, all traces that have been logged to the system. You can, always filter, sort, etc. to see, just filter down to specific traces you care about. But one thing that will be helpful to start in this case is just taking a look in to see what exactly happened within this pipeline. For any scenario where maybe if I look at the response and see that the model got things wrong, all the details logged here can help you take that further look into what exactly may have happened. So for example, maybe I start by looking at that context retriever step to better determine whether this is an issue with my RAG pipeline that I might need to continue to iterate on and take a look there. If the context retrieve looks pretty good, then maybe I jump to the model call itself and can take a look at what the response was. In this case, I had mentioned this earlier, but because we leveraged the Bedrock integration, we'll also have some metadata that we can track, including token usage, for example. So you can see details on exactly what happened in this model call. So this is going to be helpful for both, high level details on even which step of the pipeline took the most time, and then digging in to see, at which step something may have gone awry. While analyzing these results, you may also, want someone from your team or SME to annotate these traces. So by clicking on this annotate button here, also wanted to call out that you can also add human annotations to these, so you don't have to keep going back and trying to remember which traces were correct or incorrect. So as a starting place, we can add add these definitions manually, and you can also always create a custom feedback definition. It doesn't just have to be this correct score. So if you have a specific metric that you want SMEs to score based off of, you can do that here, and then they can easily add these scores right in the platform, which you then can analyze in the UI. This covers, the human feedback aspect, but we will also show our automated feedback metrics later in the demo. So much of the goal, or where we want to help, is automating that process of scoring all the metrics using OPIC and SageMaker, so that you don't have to go through this manual analysis of every single trace, since that becomes difficult when you start to scale. So with that, let's maybe jump right in. These ad hoc calls that I've shown here going to be helpful for, initial check on the model to make sure everything's working. But, just from this one call, I'm not going to have confidence in this application. So maybe once I'm happy with this initial call, I probably want to automate the process of scoring and evaluating the model on a broader set of questions. So to do that, I'll show you how you can use the OPIC evaluate function for that. So if I scroll down just a bit, as mentioned, we want to help score the model on a broader set of data. So let's first define a golden test set that our application will be evaluated on in OPIC. For demo purposes, I've just added them right in the notebook. So here's just a sample set of Comet questions. I've also included the expected answers. So that's something you can include if you have it. So in this case, it's just a predefined list for simplicity, but I do want to call out that, as you'll see later in the demo, over time, you'll likely want to add samples to this data set from real world user prompts in production. So, we might start with these questions as a first test set, but once you actually start getting live data, we can continue iterating on this and adding to it based on maybe edge case samples that aren't doing as well that we want to include next time. For simplicity's sake, though, we'll start with this list of questions. I'll use this getter create dataset method in OPIC to save this as a new dataset for evaluation. So if I jump to the UI, you'll then be able to see that saved right here. And this can be used, any number of times to evaluate different iterations of your application on this same golden test set. So this is really going to help with providing that standardization. So then, now that we have the data set defined, let's go ahead and start working on orchestrating an evaluation using the application I've defined and the data set samples I've used here. So running an evaluation in OPIC is really going to be as simple as calling the evaluate function here. The evaluate function is going to take in a few different inputs, including the experiment name, the data set I want to use, and the task you want to evaluate, as well as scoring metrics, which we'll get to in a bit, which are going to be how we're automating the scoring of this application. Once again, this is all being done in the notebook for simplicity and kind of consolidation of all of the code, but we'll talk to a little bit how you might, where you might incorporate this into a SageMaker pipeline to even automate the running of an evaluation, so you don't have to go into a notebook and kick off this code. So if I show you a little bit, let's take a step back. We need to set up this evaluate function, but let me show you how we can define some of the inputs that are going to go into the evaluation. The first step, simple, is just going to be pulling the data set that we just defined. So we've already done that, and are going to evaluate this application on the Comet questions. Next, I'm going to define the system prompt to use, which will be versioned in OPIC's prompt management solution. So if I jump to the UI here, we'll be able to see the first iteration of my prompt, and we'll be able to reuse this as many times as we want as well. Next, I'm going to define the evaluation task. Really, this just maps each dataset item to the output of our LLM application. and the context from the RAG pipeline, as you'll see in the return statement here. So my evaluation task simply just calls my RAG bot that was defined previously and then retrieves the context and output. And then finally, we automate the often manual process of scoring each of these individual traces by defining metrics for OPIC to calculate for each of the traces that comes out of the model. So in this case, we're going to use OPIC's built-in Levenshtein ratio, which is going to measure the distance between the expected response that I showed saving in my data set and then the assistant generated response from my model. We've also included an answer relevance LLM as a judge metric. The model being used as the LLM judge can be customized. So for this use case, we've also specified the Bedrock Claude Sonnet model. But once again, you could use any judge here as well if you have preferences. We do have a wide range of metric options, so that includes both heuristic metrics like the Levenshtein ratio, or a number of LLM as a judge metrics, answer relevance, context precision, hallucination. There's a number there. And then you also can always bring in your own metric definition or make tweaks to ours. So it's going to be totally customizable. No matter what metric you're using, we just want to automate that process of using your metric to score a large number of traces. So at this point, we've now kind of defined all of the inputs that are needed, and we can input that into the evaluation function that I showed earlier and can kick off this code. When you actually kick off this code, which I've done ahead of time just in prep for the demo, you will see a new experiment that is generated in Comet. So if I click into one specific experiment, I now can take a look at the results of the one that I just ran with this specific system prompt. Before I move this project to the next stage, you'll want to find a way to take a look at the model's performance, see what improvements we can make, see what failed samples there are that you might want to iterate on. So that's what we'll show you how to do in this workflow. The first thing I'll do is take a look at the configuration. I just showed you this in the codes. You already know this, but you can take a look at the model and prompt that I used for this specific experiment, and then also map that to the high-level performance metrics here. If I take a look into the experiment section, I can now also take a look at the individual scores for each trace. So I can find, you see in this specific scenario, the trace with the lowest answer relevance, and can click in to see what went wrong. And I also can even, hover over the reason for the answer relevance that was reported by my LLM judge to figure out, what went wrong and how maybe I could update my system prompt to account for this specific, the reason that is accounted for here. So then, I do some of this analysis, maybe find some trends to determine, okay, I might need to update my system prompt to give a little bit more guidance for this specific edge case. For example, what I'm asking about how to tag an experiment in Comet. So then I might do some additional iteration. You'll see in the notebook, if I scroll down a little bit, I actually go ahead and kick off a second evaluation. And the only thing we're doing, we're reusing the same code, but just going to input a different system prompt this time. For full automation, we recommend using this same code, but to set up a SageMaker pipeline to kick off an evaluation. And this can help because you could automate the process of kicking off an evaluation every time you make a change to your system. That could be a change to the system prompt like I've done here. It could be a change to the model you're using, so maybe switching from Claude to, say, an OpenAI model. It could be changing your trunking strategy or RAG approach in some way. You can certainly, since this code is very reusable and you just need to update the inputs to it, we could certainly automate this process in a SageMaker pipeline. Once again, just wanted to, what we're showing you is in the notebook just so that you can see the code quite clearly. And then, once you've either automatically or manually kicked off multiple evaluations, the other nice thing is you can start to compare those results side by side as well. So we now can take a look at what was different between my two configurations. In this case, I'm just changing the prompt. We can see the feedback scores associated with each, and then see that the more recent run that I just kicked off has slightly higher answer relevance, also a higher Levenshtein ratio. So it looks like we're getting a little bit better. It looks like the simpler prompt that I provided here actually was more successful at some of these tasks. Once I look at the high-level configuration, I can also look at individual traces, similar to how we were doing at the individual experiment level, to see how specific traces are differing. In this case, you can see some pretty significant differences in the answer relevance, so we can take a look to see which samples each of these traces performed better or worse on, and once again, looking at that Y as well. So at this point, we've used OPIC and SageMaker to run a thorough evaluation across a representative data set in minutes, saving a lot of manual iteration analysis time throughout the development process, and hopefully giving you confidence to deploy the application to production sooner after you've kicked off a few of these evaluations. You know that you've used standardized metrics, a standardized data set, and actually have some benchmark metrics that you can say with confidence. So you can say with confidence the model is ready to deploy. We do also have an integration with PyTest that can help with unit testing as you're actually working on deploying the application, allowing you to use like OPIC's built-in metrics for more robust tests and to log these tests in a centralized location. I won't cover that today, but also wanted to call that out as well. But once the model is actually in production, you'll also want to ensure that it maintains the same level of performance that you saw during the development process. So if users start to change the content and structure of their questions, the model could, say, quickly start to hallucinate, or answer relevance might change. So in order to track and detect these issues before potential end users, you can also use our tracing functionality, which I showed really briefly at the beginning, to track and score all of the production traces from your LLM application as well. So this is also going to help for observability. Coming soon in the OPIC SageMaker version will be the ability to, visualize how these metrics are changing over time. So that will be both performance metrics. So in this case, you'll see those like context precision and answer relevance scores changing over time, but also token usage and cost, which can be really key, ensuring that cost isn't creeping up over time, especially when volume is staying the same. If you suddenly see increases in costs, you might want to consider changing to a new model and run additional evaluations based on that. And in order to ensure that the next version of your application doesn't run into, if let's say you've determined there are some bad performing or poor performing traces in the application, in order to ensure that the next version of your application doesn't run into the same problems or same edge cases, something that I had referenced to earlier is you actually can use our tracing functionality to find low performing questions and then add them to your golden test set so that they're accounted for during the next round of evaluations. One way you can do that is via the UI. So, I could apply filters here based on, one of these feedback scores. Once I've, selected the ones I care about, I can either, select all or select the ones that I'm interested in, like considering as edge cases, and can add those to a data set. So once again, that Comet questions data set I had shown earlier, I could add those right here from the UI. But to further streamline things, you can also use OPIC's API to programmatically search for all of these traces, in a specific deep date range that meet your conditions. So I've also built an example of what that might look like. If I scroll down just a little bit here, you'll see we're using our search traces method to start by just pulling all traces within a specific time frame. And then if I scroll down a little bit further, we're then starting to filter those traces for, specifically in this case, we want to find traces where they're both poor performing, so they meet the thresholds for poor performance that say we've set out for this use case, both on answer relevance and context precision, but also that are more expensive, so like a larger token usage in this specific use case. So what I can do here is automatically pull all those traces, and then you can add those traces to my data set for the next evaluation as well. So instead of having to do the filtering in the UI, if that's not preferred, you could do it programmatically. And then once again, as we talked about earlier, SageMaker pipelines can always help even further automate and streamline this. So one thing you can do is bring this exact code into a SageMaker pipeline, schedule daily to automate this process of identifying poor performing traces from the last day, and then adding them to the evaluation data set on that regular cadence. So that's going to ensure that all of the edge cases are accounted for next time you start the evaluation or start the development process over again, so that next time when you deploy a model, it's also accounting for additional edge cases and likely should have better performance in production. So you'd be able to see those in the data sets, and once again, we'll then start that evaluation process over again. And so this is really going to continue to be an iterative process. You can use SageMaker and OPIC to continue this process of iterating on your application, evaluating the performance. Once you see that good performance, deploying it, and then monitoring it once again with our tracing capabilities. And this should reduce the time it takes to get each new iteration to production, and with that, improve the performance of your application for end users, since you're getting those updates more quickly. That concludes the demo I had planned for today for OPIC specifically. Something that I had mentioned at the beginning that I want to give a little bit of context on is also like how you get started and potential next steps. So if anything you saw here today was interesting to you, if you're interested in getting started with OPIC, as mentioned, it's available as a SageMaker AI partner app. So I also wanted to give you a little bit of information on what that means and how you could go about trying to get it set up yourself, since it's a pretty easy process. A couple steps. One, if you go to the AWS console here and then into Amazon SageMaker AI, you'll see this new Partner AI Apps tab show up on the left-hand side of the screen. From here, you can jump into Comet. Here, you'll be able to see details on pricing and some of the options for infrastructure costs based on the number of users and traces you're planning on logging. That configuration will be able to find later. Once you've reviewed this, have decided maybe the number of users and traces you're interested in, you can just click this Go to Marketplace to subscribe button to purchase a license. So it's going to be completely self-serve. And then once you've purchased that license, we can go back to AI Partner Apps, My Apps, and then you'll see the Comet app show up here, and we'll be able to go ahead and configure and deploy it. The deployment process is really all managed by SageMaker, so the configuration section is just going to be defining, for example, the instance size and some other metadata about the number of users, etc. But you're not actually going to have to deploy it yourself. It'll take a little bit of time. You click deploy, and it'll be done for you and be ready within the day. So if this is of interest, let us know. There'll be a link to the documentation at the end of the presentation as well that gives you a little bit more of a deep dive into this process. But let us know if you have any questions or if this is something that we can help you get set up.
Awesome. Thanks so much, Chase. Let me take over the screen share. So Chase just went through this full process, but as a reminder, if you're interested in trying this out for yourself, you can go through the steps that Chase just mentioned through the SageMaker console, partner apps, like Comet, view details, and then subscribe by Marketplace. And if you have additional questions that we haven't answered here, the best course of action is to look up the public documentation or to contact your AWS account manager, who will be happy to help you set this up or loop in the relevant people from the SageMaker or the Comet teams. So that concludes our planned introduction to the Comet SageMaker partnership on partner apps, as well as the deep dive technical demo of building a RAG-based AI assistant using the two tools in concert. I'd like to open it up now to a general Q&A. So if anybody has any questions, please feel free to either post them in the chat or to speak. We appreciate you taking some time out of your day, and we hope that you'll give it a try and see how much value it can bring to your team.